Hi, today I will explain you the 30 days lecture series in Verilog. So if you see, so one second. So gray code to binary conversion, that is day 3. So what is a gray code? Gray code is actually like this is the decimal number and this is the binary representation. So each and every code is differ by 1 bit position, that is gray code. So if you see this uh, so this first code 000 and 001, okay, this is differ by 1 bit, and 001 and 011, okay, so second bit is differ. So this is actually non-weighted code, we call as a non-weighted code. So this is each and every bit is differ by 1 bit position, that is a gray code, okay. So here we need to convert gray code to gray to binary and binary to gray. How to convert this gray to binary and binary to gray, we'll see, okay. So this code doesn't have any weight, so it is unweighted, we can call it as unweighted code, okay. In the above table, successive gray codes are different in 1 bit position, so these are 1 bit position, and this code we can call as the unit distance code, okay. Gray code is a unit distance code. And how to convert a binary code to gray code means, so these are the steps to convert binary code to gray code. So write the leftmost MSB bit in binary code. So whatever the MSB bit is there, so as it is you write, okay. And compare the successive 2 bits starting from MSB in the binary code. So if 2 bits are same, then output is 0, otherwise output is 1. So like we need to do the XOR operation, okay. So 2 bits successive bits are same, then output will be 0. If so 2 bits are different, then output will be different, okay. Output will be, we need to give 1, okay. Repeat the above step till LSB of the gray code is obtained, okay. So here there is an example. So here if you see, so I need to convert the corresponding gray code to binary. So if you see, this is my number, okay. So this is my binary representation. 1000 is my binary representation. First I need to convert to gray. So first what you need to do, you need to take out whatever the MSB bit is there, you need to copy as it is, and next you need to do the XOR operation. So 1 XOR 0 is you are getting 1, and 0 XOR 0 is you are getting 0, and 0 XOR 0 is means you are getting 0, okay. So like this we can convert whatever the binary representation into gray code conversion, okay. And coming to gray to binary conversion, so this is my gray code. So first MSB bit of gray code directly you write, you copy this, and this binary value and this value we need to do the XOR operation, okay. So 1 XOR 0 means you are getting 1, so both are different means the output will be 1, both are same means the output is 0, like XOR operation only. So we are doing the 1 XOR 1 means the output is 0, and 0 XOR 1 is the output is 1, okay. So like this we are doing the binary to gray and gray to binary conversion, okay. So we'll go for the programming part. So I will open the programming code. So I will tell you how to execute in EDA playground and Xilinx Vivado and Quartus Prime and Model Sim, okay. We'll see this circuit also, how the tool is converted your code into circuit, okay. So first we'll see binary to gray. So binary to gray, if you see here I wrote the both RTL code and Testbench. So module, and module name is binary to gray, and you need to declare the port list declaration, so binary and gray, okay. So you need to declare the inputs. Input is 3 down to 0 binary, output is 3 down to 0, so there are 4 bits, no. So I am declaring with a vector, output 3 down to 0 gray, okay. So assign, so based on my conversion, so MSB bit will be directly coming to this gray, no. So assign gray of 3 equal to binary of 3, and it will do the successive XOR operation, okay. Assign gray of 2 equal to binary of 3 XOR of binary of 2, and assign gray of 1 equal to binary of 2 and binary of 1, and assign gray of 0 equal to binary of 1 and binary of 0, okay. So this is my RTL code, okay. So coming to the test bench, so module, and what is my module name? Test bench binary to gray. Okay, binary underscore to gray. Okay, so we need to declare the variables for the test bench. Okay, so binary value, that is binary 3 down to 0, I am declaring with reg data type, and gray I am declaring with white data type, and integer I am declaring. Okay, why? Because in the test bench I am using for loop, so integer I am declaring. So next you need to instantiate your design in the test bench. How to instantiate a design name followed by the instance name, and this is the connection name, connection by name. Okay, so whatever the variables outside the bracket are design inputs and outputs, and whatever the variables inside the bracket are test bench inputs and outputs. Okay, initial, begin. Okay, so for executing in the EDA playground, you need to use these two commands. Okay, $dump file binary to gray dot vcd, $dump as 0 comma test bench comma binary to gray. Okay, so here binary value I am initializing to 0, and I want to display $display input binary output gray. So for I equal to 0, I less than 16, I equal to I plus 1. I want to see the 16 possible combinations. Okay, decimal value. So total 16 possible values. I am giving the binary value, and how it is converting the binary to gray. Okay, I am giving the stimulus. Okay, binary values I am giving. Okay, so every 10 minutes I want to display that, and after performing this I need to increment this binary value. Okay, so end and dollar finish. Okay, so this is my test bench file. So this I am executing in EDA playground. So go to this EDA playground. So whatever the RTL code is there, just copy this, and here we need to write the design, and test bench, copy this, and here paste, and go to the tools and simulator, Aldec Rivera, and open EP after run. Okay, save this file and run this file. So here you got this simulation waveform. Okay, so here if you see, so 0, so this is binary, and this is below is a gray. Okay, these are the I values. Okay, so you can get in radix, you can get in hexadecimal, decimal. I want decimal means decimal I can see. So suppose if you want binary means binary you can see. So if you see for 1110, you are getting gray as what 11. Okay, like this 1110. So three bits 100, 110, 101, 111. Okay, like that 3 bits 110, 101, 111. Okay, like this we can get 4 bits also 100, 110. Like this it is converting gray to binary. Here also you can get. Okay, so binary to gray. Okay, you are converting binary to gray. So depending on the 4 inputs, so I am getting this output. Okay, so it is converting binary to gray. Okay, so this is my binary to gray. And next coming to Vivado, so go to file, project, new project, and next I will give the project name as what, code converters. Okay, so choose the location. Let us take so training and development, and VLSI design, and 30 days RTL. We are in this one, no? So here this folder, this is the path. Okay, so select this, next. So this is the RTL project, and you add the module name. Okay, so what is my module name? So just this is my module name. So copy this and paste here. Choose the location. What is my location? Code converters. In this I want to save. Next. and finish. Yeah, my module name is also same. So this is binary to gray code converter. So here go to this and here copy this and paste here and save. And coming to the test bench, go to the simulation and add the simulation sources. Okay, so what is my test bench name? Test bench underscore binary to gray. Okay, so give that name and choose the location where I want to save. Select OK and finish. OK. Yes. So this is my test bench. So copy this test bench and paste over here and save this. So my design is instantiated in the test bench. Okay, so if you want to see the means elaborated design, okay, so open the elaborated design. So it will take time to get the netlist. So the code is converted, so means based on my code only it is converted into binary to gray code conversion. Okay, so first directly it is coming and next it is doing the so XOR operation. Okay, XOR operation it is doing, and coming to the simulation, go to the simulation, run behavioral simulation. So you can see in this waveform this untitled fit to page. Okay, so you can see like radix and binary you give. Okay, radix binary. Okay, so depending on this 0 0 0 the binary is same only, 0 0 1 is also same, but 0 0 1 0 you are getting the gray as what 0 0 1 1. Okay, 0 0 1 1 means 0 0 1 0. Again 0 1 0 0 means 0 1 1 0. Okay, so like this 0 1 0 1 means 0 1 1 1. Okay, like this it is converting your binary code into gray code. Okay, so like this we can see. Okay, yeah, so this we can see. So in the TCL console also I got the output, we already seen in the EDA playground. No? Same in the TCL console also it is converting binary to gray. I wrote the display now, $display, so that's why I wrote the system task, that's why it is displaying in the TCL console. Okay, so next coming to the Quartus prime. Okay, so if you see the Quartus prime, first new project, let us take next. Okay, so here binary to gray, no, binary to gray, I need to create these separate files. Okay, so here this is my RTL code. So binary to gray, copy this and you need to choose the location. Okay, so here 30 days, yeah, day 3, binary to gray and sim folder. So select this folder and make sure that your this RTL file module name and your file name should be same. Okay, so this project name also, so let us take what is my module name, binary to gray. Okay, so binary to gray, binary to gray. Okay, So that is my module name, binary to gray. And next create empty. Okay, add that file. So binary to gray in RTL. So this is my binary to gray, and I added that file. Next, select any FPGA family. Next, and finish. So my file is added in this instance. Okay. Next, right click, start this analysis and synthesis. So I got 0 errors and 1 warning. Okay, so expand this, and next see this netlist viewer, and open this. So I got this. So in the Vivado you got the same thing, no? So Vivado also we got the same thing, whatever we have seen in the elaborated design, that I got in the Quartus prime. Okay, so like this we can see the netlist viewer in the Quartus prime. Okay, and coming to this model sim, we can see the simulation in the model sim. So file, and new project. Okay, I want to close this previous project. So project name is let us take the module name only, binary to gray. Give the module name same as module name. So copy this, and here you paste. Browse the project location. Okay, so where is the project location? In the 30 days, day 2. So this is my project location. Okay, sorry, day 3. No, we are doing day 3. Yeah, sorry, day 3. 1 second. Browse. Training and development. The VLSI material. 30 days. Day 3. I created this binary to gray and sim folder. Okay, I need to select this path. Okay, and add the existing files. So what are the existing files? So binary to gray, first you add the RTL file. Okay, and next add the TB file. Okay, close. Okay, select this, right click, and compile selected. So compile selected, and go to library, and go to work function, and Testbench we need to simulate. So simulation started, and go to this Testbench, add wave. Okay, here it will be added. And DUT also I am going to add wave. So here you can group the binary and Testbench files and DUT files. So here if you see Testbench, these are the Testbench files. Okay, so just to group this, group TB, and here these are the DUT files. Just 1 second. This you group, these are the DUT files. Okay, and you need to go to run all. Okay, no. Okay, you can see the waveform. Just expand. You can see the waveform. So fit to page. Okay, so you can see the simulation. So for 0 0 0 0 1 you are getting same thing only. 0 0 1 0 you are getting 0 0 1 1. Okay, 0 0 1 1 you are getting 0 0 1 0. So like this we are converting gray to binary conversion. Okay, so this is what gray to binary conversion. Okay, and coming to the binary to gray conversion. Okay, so binary to gray conversion, if you see, so the binary to gray we already seen. Gray to binary conversion. Okay, so if you see this code, so so binary to gray conversion module, gray to binary, and these are the port list. Input 3 down to 0 gray, output reg 3 down to 0 binary, and always at the rate gray. Okay, always at the rate gray. So when there is a change in the gray, then here by so b in equal to gray of 3 only, and b in of 2, what you will get, we already seen in this, no, b in equal to b, so gray of 3, and here something b in of so b in of gray of 3 and gray of 2, b in of 1 equal to b in of 2 and gray of 1, b in of 0 equal to b in of 1, gray of 0. Okay, so alternate we need to do this. And test bench, same thing, module, this is my module name, reg 3 down to 0 gray, and wire 3 down to 0. Just I will see this one more code. Yeah, so this is binary and integer. You need to instantiate your design, and this is for $dump file $wires for generating this waveform, and $displays for displaying, and I am using the for loop for generating 16 variables, and gray equal to I am initializing, and I am making some delay for a visibility waveform, and $display the system task. Okay, for displaying this, so it will display all the 16 possible combinations, and $finish is for terminate the simulation. Okay, so this also you can try. So here, so gray to binary, just so copy this code, go to EDA playground, paste, and copy the test bench, and here test bench paste, save this file. So make sure that you select the tool as Aldec Rivera, and open EP waveform, run this code. So you are getting the waveform like this. Okay, so that means binary, with respect to binary, so what are the possible gray you are getting. Okay, so in here also we can see in the in this log file also, depending on this gray code I am getting the binary code. Okay, so depending on this gray value I am getting this binary value. Okay, if you want to see in the EDA playground, just in this same project only, so what you need to do, just I am closing this. Here go to the design source. Okay, here gray to binary, no, so this module file I will copy this module name, and add the design source, next, so paste here, choose the location, code converters, select, okay, finish, okay, yes. So gray to binary converter, so go to this code and copy this, and here you paste, save. So this is my design file, and go to simulation, add the simulation source, create the simulation source. So this is my test bench module name, give this module name, copy this, and here you paste and choose the location, code converter, select, okay, finish, and okay, yes. So this is my test bench. So go to this code and copy here, copy this, and paste here, save. So if you want to see the design, you need to right click and make as a set as top module. Okay, simulation also, if you want to see the simulation, you need to make set as top module, then only we can simulate and we can elaborate the design. Okay, so I am elaborating the design. This is actually gray to binary. Okay, gray to binary. So binary of 0 like this, gray of 3 like 2 like this, it will execute. Okay, so go to run simulation, run behavioral simulation. So you can go to this waveform, fit to page, here gray and binary. Okay, if you want to see in binary, so just radix and give it as binary. Okay, so 0 0 0 is same only, 0 0 1 is same only. So gray is 0 1 0, binary is 0 1 1, gray is 0 1 1, binary is 0 1 0, gray is 0 1 0 0, binary is 0 1 1 1. Okay, like this we can simulate the gray to binary. Okay, so here yeah, so we can simulate like this. One second. This card, and this also I am using. So in the TCL console also you need to get the output. So if you see in the TCL console, you will get this one. Okay, so gray, with respect to gray input, you are getting the output in terms of binary. Okay, input is gray and output is binary. Okay, so like this we can see in the TCL console also. Okay, so coming to Quartus prime, so again file, go to 1 second, I'll close this. Yeah, I'll open this Quartus. So new project wizard, next. Okay, choose the location, 30 days and day 3, gray to binary sim. Okay, this is my path. Okay, and so I created RTL sim and TB, no. So gray to binary RTL. Okay, this is my RTL file. 1 second, I'll close all. This is my RTL file. So this project name gives same gray to binary, no. So gray to binary, gray to binary, next, and add the RTL file. Okay, what is my RTL? So gray to binary, this is my RTL file. Okay, open, next, yeah, select any FPGA family, finish. So my RTL code is added. Next, go to analysis and synthesis, start. I'm getting errors. Okay, so what is my module name? Gray to binary. Yeah, gray to binary only my module name. So I want to check, I'm getting error. Okay, okay, so just I will see in the model sim, just file, new project. Okay, project, not open project. Once close this. file, new project. Yes. So what is my project name? So project name give as gray to binary. Copy this and paste here. Choose the location. So here day 3 sim folder. So here browse. One second. Not binary to gray to binary, no. So gray to binary, this sim folder. Okay, and okay, and add the existing file. Okay, browse this, go back. Yeah, gray to binary, RTL, add this file. Okay, add existing, browse, and go to TB. Testbench file also I need to add. Okay, close. Select this, right click, and compile selected. Gray to binary I am getting error. Yeah, I need to check this. Okay, just you try this. Okay, so hope you understood this code, how I am executing in the Vivado and EDA playground and model sim. Okay, and Quartus prime. Okay, just you practice this EDA, this gray to binary also. Okay, thank you.